Hello everyone, Mr. Havel here again, checking out 9.0. All right, so all chapter 9 is we're talking about a bunch of conics. Okay, so what is a conic? So if you look here in the cool little diagrams on the right, they're just different sections where with the plane being cut in this hourglass in different directions. Right, so if you look at kind of the red is the cones, the kind of blue purple is the plane, and then the yellow highlights, those are the actual conics themselves. Okay, so right here you notice this is our parabola shape. So if we cut one of the cones at a diagonal, circle is if we do kind of a perpendicular with it. Ellipse is if you notice, very similar to a parabola. The difference is that the plane goes in one side of the cone and out the other, whereas this other one doesn't totally. We're missing it down here at the bottom. And then a hyperbola is kind of, I guess, somewhat like parallelish to the cone, and it just cuts off the outside corner of the top and the bottom. Okay. So I'll give you time you may want to pause the video and read over some of the stuff. We've got a nice table here that breaks down all the different types of conics. So for example, we've got circle, ellipse, hyperbola, and which direction it opens, up or down, or sorry, horizontally, or what else. And so one highlight that I want to bring your attention to is if you notice circle is equal to r squared, but the rest of them, and you'll see a little bit further down, are, I guess, one more, the hyperbola. Those guys are equal to 1. So that's a big highlight that we want. And so also, yeah, some of the things that you'll read here, you should really pause the video and look into it. So here the radius is going to be the same, where in this case A and B would be a little bit different for the ellipse. Same thing for the hyperbola. The ellipse has the plus sign, whereas hyperbola has the minus. So little stuff like that that is really going to help you as you read through this. Okay, these equations are really good here. I'll also talk about how to just calculate it without having to necessarily remember what is H and A and K and B and all that kind of stuff. Okay, so let's jump into it. Again, please pause it and read over some of those highlights there. So if you notice on this first one here, okay, we're going to go through and solve it out. Now, what does this shape look like? Right, so it kind of makes me think of a circle at first, but because the square root of 64 would be 8, but if you notice, there's something out in front of the x values, right? So the x and the y values. So if those were both 1, this would just be a circle, okay? And so what we're going to do is we're going to go through this and solve it out. So actually, since in this case the 4s match each other, what I'm going to do is divide everybody by 4. Okay, so then we end up with x squared plus y squared is equal to 16. Now again, we'll see an example where maybe that doesn't work because we've got to make sure these guys match. If they match, it's a circle. If they don't, then we're going to be dealing with an ellipse, which we'll check out later. So a couple of highlights. Center, we don't have an H and K, so my center is going to be 0, 0. And then my radius squared is equal to 16. So therefore, my radius for this guy is going to be 4. Okay. It says to graph it, so we're going to have my center at 0, 0. We've got a radius of 4, so we'll go out 4 in each direction, and then as best as you can, make a nice beautiful circle there. Okay. All right, now moving on to number 2. Okay, so number 2 is definitely looks a little bit different, doesn't look quite as straightforward as that first one that we did. So we need to determine, what does this even look like, right? So if you remember, we'll have to do completing the square, which you guys saw last year, definitely in Algebra 2 Honors. If you're unsure, you can always come get some extra help. Okay, so with completing the square, what you want to do is you want to get all of your variables, your like variables together, and then all of your constants on the other side. Okay, so what I'm going to do is I'm going to add this 8 to the other side, and then bring the x's together. Okay, and now there's a few ways to go about it, but the way that I do it is we're looking at this guy right here. What we're going to do is we're going to keep it like that, and then to make a perfect trinomial here, so we can get a perfect square, we're going to add something to it to make it perfect. And so therefore, if I add something to the equation, I need to subtract something from the equation. Or sorry, subtract it from the same side, add it to the other side. So if I add 2 to one side and add 2 to the other, that's okay because I was even on both sides. I said subtract because a lot of times sometimes you'll see add a number and then subtract a number. But remember, we want that number to be on this side, so we're going to end up adding it anyways. So this is kind of a shortcut. Okay, and then we still have this 9y squared. So now in order to get the blank, this is ax squared plus bx plus c. I won't do this for everyone, but we're going to do b divided by 2. And then what we're going to do with that is square it. Okay? And so our b divided by 2 would be negative 2 divided by 2, which is negative 1. And I like to split it up. I'll do a little arrow here. I like to split it up here. I'll show you in just a second. So I added 1 to the equation. So if I add 1 to the left side, I need to add 1 to the right side. Now this guy now I can factor it, and it comes out to be a perfect square, right? And so if I factor this guy, I'll kind of go up here to the top for just a second, just so I can show you. We're going to have x minus 1, x minus 1. And so that would match. We've got 2 perfect matching factors there. And so I would have this x minus 1 squared plus 9y squared is equal to 9. Now a couple of things, we do now have an h value, okay? And the other thing is, if we notice last example on example 1, these guys, the coefficients out in front matched each other, where this time it doesn't, right? So I know it's no longer a circle, so what I'm going to do is I'm going to go about and get this guy to equal 1. I want the right side to equal 1, so I divide everybody by 9. So what we're going to do is I'm going to do x minus 1 squared over 9 plus, I know 9 over 9 is 1, but in this case it might be helpful just to show you y squared over 1. Okay, so because I want to have an a and a b value. So we know this is going to be an ellipse. Okay, and we know that for a couple reasons. Number 1, we've got a plus. And number 2, what we talked about here is those guys don't match each other. So therefore it's not a circle. Okay, so not a circle because of these coefficients not matching. And an ellipse instead of a hyperbola because of the plus sign right there. Okay, so as we do this, our center on this guy is going to be at 1, 0. Okay, so the 1 came from this right here, and then the 0 came since I don't have a k value. So 1, 0 is my center of this ellipse. And now how to draw the ellipse is, I always think about it, if you look at the equation from the first page, it's a squared and b squared. So in the x direction, it's nice with an ellipse because it's just the square root. So we'll say a squared is equal to 9, the denominator under the x. So a is equal to plus or minus 3. All right, so that tells me that in the x direction, I'm going to go out 3. 1, 2, 3. Do a positive 3, and then go to the left 3 as well. Okay? Now, the reason I left this 1 in the denominator under the y is it just helps me see it a little bit better. So my b value is going to be plus or minus 1. So I'm going to go up 1 and go down 1. Okay? Now, the center, we're not going to connect the points with that, but we're going to try to make this look like an ellipse the best we can. Cool. So there's our center, and then our vertices there. They're outside points, both for our major and minor axis. Okay. Now, number 3. Okay, so moving on to number 3 here, we've got 16x squared minus 4y squared minus 64x minus 40y equals 100, right? So there's definitely a lot of stuff going. So we're going to get all the numbers, which they already are, all the constants on one side, and then group up the variables, right? So our variables are going to be 16x squared minus 64x minus 4y squared plus 40y. Now, since both of them have a coefficient other than 1 in front of them for the y and the x squared, we've got to take those out. Okay, so we're going to take out a GCF, but we don't take it out of the entire problem. Okay, so we take it kind of just per variable. So we'll take out the 16 here, and this leaves me with x squared minus 4x plus something minus 4, because I'm taking out that GCF, which is y squared now, minus 10y plus something is equal to 100. Now this time I added 2 things to the left-hand side, so I need to add 2 things to the right-hand side. Cool. Now I'll add something that I didn't tell you in the last problem, just kind of build onto it. So when we solve this, we're still going to have, I like to, a lot of times, I'll start writing my answer already. So I've got 16, I know it's going to be x something squared, and then minus 4y something squared is equal to a big number. Okay, the reason I kind of like to start writing my answer is if you notice here, I take my b value, my new b value, and divide it by 2. Negative 2, and then I square that, and 4, and that goes right there. Okay. Now before I go any further, I want to show you from above, right? So if you notice, this value is always going to match each other. So right here, so that b divided by 2 is always that number for your perfect square, okay? Or for your repeated term there. Okay, so that is nice because if I know that the b divided by 2, I don't have to like keep factoring or anything like that. So I know my b divided by 2 here is negative 2. So it goes right there. Now on this other one, I do b divided by 2 again, which is equal to negative 5. Again, that goes right there. And then if I square that, oh, what happened? Sorry, I think my computer froze. Oh, there we go, we're back. Okay, sorry about that, my screen went away. And so we square that, which is 25, and that goes right there. Okay, so now the last part, this is kind of the biggest, kind of one of the trickier problems we can have, is on the last part, we just did whatever we added to the left, we added to the right, right? So we might be thinking like, okay, well, I did 4 and 25. Perfect, I'm done. But the tricky part is whenever you take out a GCF, you kind of have to redistribute it back in, okay? And so what we did is we really actually added on the left-hand side. For this value, we added a total of 64. Yes, there's a 4, but because of that GCF, this is actually going to be 64. Same thing for the second term, but this is a negative 4 times 25. So I'd add, so negative 4 times 25 gives me negative 100. So I'm going to add negative 100. Okay? And so I put all that together. And so 100 plus 64 minus 100 would just be 64. Now, again, I know this is not a circle for a couple reasons. There's the coefficients out in front don't match, and then we have a negative. Okay, so that tells me that we are dealing with, in this case, a hyperbola. Okay, so the hyperbola, again, we know that because of the minus and the different coefficients out in front there. Okay, so let's get this problem equal to 1. So divide everything by 64. So I end up with x minus 2 squared over 4 minus y minus 5 squared over 16. Okay, so kind of pay attention as we do these problems. Pay attention to these numbers right here. Cool. And then so that is equal to 1. Now be careful, the x and the y don't always come in alphabetical order, right? So the y could potentially be in this first fraction here. So, but in our case, the center stays the same. So opposite h, opposite k. So my center for this guy is 2, 5. So 2, 5. Perfect. Now, a few things that we need to do with this is we're going to look, again, it's the square root. I really like looking at this. I don't think you guys can see. I like looking at this. So that tells me the x direction. So in the x direction, is that A or B or whichever one? We can check out above. Okay, but I like in the x direction because it's underneath x, it's going to be the square root of 4. So we're going to go plus and minus 2 in each direction in the x. And then the y, because it's 16, in the y direction, we're going to do plus or minus 4 in the y direction. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and now we'll explain more as when we do the section, but with a hyperbola, it's kind of funny. I'm making a little dotted box here. It doesn't actually go in the box or anything like that. Okay, so we'll talk about this. We'll go more in depth here later in the sections, but this box, just so you know, if I connect corner, center to corner, that gives me an asymptote. Okay. Same thing over here, corner, center, corner. That gives me another asymptote. Okay, and so those guys are, again, we'll talk about that when we go into the section itself. But as an intro here, we'll leave the extra information out. Now, is it up above here like this and down here, or is it the left and right? Okay. The way that we know which direction it's going to go is by whoever comes first, okay? So whoever comes first is going to tell me which way it opens. So think about, what do you mean opens? So it opens in the x direction, okay? So the opening will be kind of facing, I don't know how you would say it, like eating the x-axis or something like that. So my hyperbola here is going to go like this, follow the asymptote, touch that, in this case, that A value, and then go that direction, okay? So kind of go like this. That is what our hyperbola looks like. Now, if you recognize everything else besides the hyperbola is the dotted line, because those are all just reference points to help me draw it. So if I went back, our real graph, if you look on it, would look like this without all the extra stuff on it. Okay, so that's just the hyperbola itself. That's what our graph would look like. Cool. Okay, cruising on. We got a couple more problems here. All right, example number 4 here. The biggest thing that if you notice right away, there is a y, but there's not a y squared, okay? So with the fact that we only have x squared, we don't have the y, that eliminates our circle, our ellipse, and our hyperbola, right? So the only thing that's left is a parabola. So parabola, with it could be open, you guys have seen, you're very comfortable with it opening up and down. It can actually open left and right as well. But for this one, it all determines which way it opens based on which variable is not squared. Okay, so here we're going to get the y by itself. So we'll add over the other terms. So we've got y is equal to x squared minus 8x plus 13. Okay. Now it looks good like this, but we really want it in HK form. Okay, so this is a trick here. Yes, there's the 13, but I'm going to group to, when I do the perfect square, completing the square, I'm going to group those two guys together. Okay, so what we're going to do is we're going to have y is equal to x squared minus 8x plus something. And this is where I was talking about earlier in the video. If I keep it on the same side, I'm going to also minus that same thing. So I don't change the equation at all. Now to get that value, again, b divided by 2, so that's -4. I personally would start setting up my equation. Yeah. And then this value squared is 16, so that goes there. Since I added 16, I don't have a GCF. Since I added 16, we are going to subtract 16. So the outside here becomes -3. So once we have something like this, you guys should be pretty comfortable with this idea. Our vertex is at 4, -3. You guys have seen this a few times in your life. A value is 1, so it'd be up 1, or over 1, up 1. Beautiful. All right, number 5. So number 5 here, again, we see an x and a y squared. So that kind of gives me an idea that it's one of my first 3 conics, circle, ellipse, or hyperbola. But let's put them all together, right? So I noticed there's a minus x, right? So I'm having a good feeling that this is a hyperbola because both the x and the y are not positive, okay? So what I'm going to do is I'm going to reorder it so that the positive one comes first. So I'm going to still keep this guy, the y squared, first on this. I see I have to complete the square, so I'm going to do that. Now I'm going to subtract this 100 over to the other side. And then here, this is minus x squared. So I don't have to do anything with that, completing the square rise, because it is, it's just an x squared, okay? So take out a GCF here, 25. So we have y squared minus 4y plus something, minus x squared is equal to -75 plus something. So I like to set it up, 25, y, I'm not going to say minus, y something squared minus x squared is equal to something, okay? And so as I go through this, completing the square, b divided by 2, which is -2. Again, that goes right there. And then when I keep going with this, I square it, which is 4, which goes right here. Because I have a GCF, I technically added 100, and so there'd be 100 right here. So -75 plus 100 would give me 25. Now again, we know this is going to be a hyperbola, okay? Because a big sign is that negative right there. Now I want to get this to equal to 1, so I'm going to divide everybody by 25. So we end up with y minus 2 squared. It's 25 over 25, but I'm going to keep the 1 there just to remind myself. And then this is equal to 1. Now when I find my center on this guy, be careful because like I said, make sure the x and the y are in their correct positions. So my x is actually 0 and my y is actually 2. So right here. Now, the only difference is you can memorize who's A and who's B, but it's really nice because as long as you just pay attention who it's underneath, in the y direction, my distance is going to be the square root of the denominator, which is 1. So I'm going to go plus and minus 1. Now in the x direction, I've got square root of 25, which is going to do plus and minus 5 from the center. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, since this is a hyperbola, I can make my imaginary box. My asymptotes cut through, corner, center, corner. And now this one opens up in the y direction because y is the positive one, right? So this one is going to be a huge hyperbola, starting from those green points and shooting around like that. Ta-da! All right. Okay, number 6. I believe just a couple more, and then we are all done here. Okay, so number 6. If you notice again, you're missing an x squared. So this will be kind of a new one for you guys. Is I want to get that x by itself. Okay, and so what I'm going to do is, it doesn't really matter which direction, but I want to try to make that x positive if possible. So what I'll do is I'll bring this y squared plus 4y plus 16 is equal to 3x. So I kind of switch spots with the 16 and the 3x. Okay? And so as I go through and solve this, what I'm going to do is I'm going to complete the square. So you can always check, is this trinomial, can I have it come out with the same terms? So yes, 16, 4 times 4 gives you 16, but unfortunately it doesn't add to the 4. So it doesn't work, right? So we've got to complete the square. Plus something minus something plus that 16 is equal to 3x. Now we'll get rid of that 3 in temporarily, okay, in just a second, or momentarily. Working on my words here. So we'll have something like that equals, right now we'll have the 3x. Cool. And so what goes there is b divided by 2, which is 2. Now whatever that value is squared goes in the blank. I don't have a GCF, so it also goes there. All right, so right here will be a plus 12. Now I want to get the x by itself, so I'm going to divide everybody by 3. Now I'm going to switch it around just so that the x is first now. So I have x is equal to 1/3 y plus 2 squared plus 4. Now this, again, looks a little bit tricky because for our vertex, normally we would say -2, 4, but remember it's backwards. Okay, it's still this right here is still the negative version of it, but my x is actually going to be here, and then my y is going to be the opposite inside there. Okay, and so you can look at the formula that was on the first page there. So my vertex for this is 4, -2. And now this idea here of the 1/3 is very similar to this idea that we did prior. We go over 1 up that squared times a. Well, we do kind of the same idea, but completely opposite, right? So instead we're going up 1, and then in this case, right, 1 squared times a. And our a in this case is going to be 1/3, so we'll go 1/3 of a block. So from here we go up 1 and then like just a tiny bit, and then reflect it over. Ta-da! Okay, so very similar to the parabola that you guys know and love, but some slight differences. Awesome. Alrighty. What do we got? 2 more? We got 2 more. We can do this. All right. Number 7 here. So 7, we notice we've got a couple squareds there. So let's get all of the variables on one side, all the numbers on the other. If I add this y squared over, it's going to be positive. The x is already positive. So I can already tell that this guy's going to be an ellipse. Okay? At least an ellipse. It might be something fancier than ellipse in the circle persuasion. So I've got x squared minus 6x. Now I'm going to add this guy over. So plus y squared minus 10y is equal to 2. All right. So now I'm going to complete the squares. So this is going to be x squared plus y squared is equal to something. So here this will be x squared minus 6x plus something plus y squared minus 10y plus something is equal to 2 plus something plus something. Cool. What are those somethings? So for this first ones, we're going to take b divided by 2, which is negative 3. That goes right there. And square that. Well, bam. So that is 9. Now here, for the next one, it's going to be the b divided by 2, which is negative 5. Oops, I forgot to add the 9. Since the GCF is 1, add the 9 to the other side. This guy goes right here. Square it. And goes right there. And since the no GCF or GCF of 1, we also add it to right there. So if I add those together, we've got a 36. Cool. So now if you notice, a couple things that tell me now that this is a circle is my coefficients match, aka they're 1, and it is a plus. Right? So the nice thing is I can just leave it as is. I don't need to set it equal to 1. So my center of the circle is going to be 3, 5. And then my radius, at least radius squared, is 36. So my radius is going to be 6. Cool. So 3, 5, well, bam. And then 1, 2, 3, 4, 5, 6. 6. 1, 2, 3. And okay. Let's look how beautiful this circle is going to be. Nice. Let's bring that over there a little bit. Perfect. Okay. So hopefully your circle looks a little bit better than mine. Cool. Okay, last one. We look here, we've got an x squared, we got a y squared. They're both positive. They got different coefficients. I'm going to take a wild guess and say this is an ellipse, but let's see if we can solve it out. All right, so let's bring this 59 to the other side. We'll get our x's together, so plus 16x plus 25y squared plus 50y is equal to 59. We definitely got to take a GCF out, so we've got 4x squared plus 4x plus something plus GCF of 25, y squared plus 2y plus something equals 59 plus something plus something. Cool. So I would set up my answer. So I've got 4x squared plus 25 y squared is equal to. Now at this point you can tell we've got a plus, we got two different coefficients, so this guy is definitely an ellipse. So we're going to go through and complete the square. So b divided by 2 is 2. That goes right there, positive 2. We'll square it. That goes right up in there. I technically added 16, so I'm going to add 16 here. And our second one, we've got 2 divided by 2, which is 1. Wabam. Boom. Square that guy. Believe it or not, it's 1. Multiply that out, plus 25. That's a 25. Okay. One of the harder parts of this problem is adding these three numbers together. Let's see if we can do it. We got something like 100 there. So now, since we know it's an ellipse, we know we want it to equal 1. So we're going to divide by 100. If you notice, I brought it up earlier in the lesson, but this guy is the other coefficient, and this one is the first coefficient, equals 1. Right, so our center is going to be at -2, -1, -2, -1, and this one's an ellipse, right? So this is an ellipse, so in the x direction, under the x, it's going to be the square root of 25. So we're going to go in the plus and minus 5 direction for in the x. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then our y is going to be the square root of 4, which is plus and minus 2 in each direction. So this is our last super beautiful ellipse. Not too shabby. Okay, I hope you guys enjoyed that. Please tell a friend. This is the intro to conics. Have a good one.